Think math.
The area of a circle is pi times the radius squared. Everybody has that one memorized. But where did it come from? Why is pi in there, and why is the radius squared? One tool from last time is enough to rebuild it in front of you. Last time we found a sector's area is a half, times its arc, times its radius. And a circle is simply a sector whose central angle is 360 degrees. So the formula applies as it stands. Only one thing changes. What goes into the arc's place? At 360 degrees, the arc is the circumference. The picture makes it clearer. Cut the circle into very fine slivers and lay them out in a single row. The base is all the slivers' bases joined up, which is the circumference. The height is still the radius. The circle has unrolled into a triangle whose base is the circumference and whose height is the radius. Now put the numbers in. The circumference is 2 times pi times the radius. Drop that into the arc's place and you get a half, times 2 pi r times r. The half and the 2 cancel, and the radius appears twice. Pi times the radius squared. The formula you memorized built from scratch. Arrange the slivers differently, and the answer holds. Interleave them, one pointing up and the next pointing down, and they close up into something near a rectangle. Its width is half the circumference, its height the radius. Width times height is pi r times r, which is pi times the radius squared again. Rearranging never changes an area. So, the circle's area formula is the sector formula with the circumference dropped in. Cut it up and unroll it, and you get a triangle on the circumference with the radius as height. And substituting gives pi times the radius squared. That closes out circles and sectors. From next time, we move on to polyhedra and solids of revolution. See you in the next one. A sip of math every day here at Think Math.